How to access our website. Go to any browser and type search creators. Click on the first link. Now you have entered our home page where 50k plus study materials are available along with 1000 plus project ideas. We have 10 plus expert members in our team and we also support 50 plus engineering domains. In navigation bar, select University Study Materials. There are three streams available: computer science, information science, and artificial intelligence and data science. For now, we will click on computer science. Now we will be able to access all the study materials of different subjects of different semesters.
To Search Creators YouTube channel. In this video, we are going to look at the further topic in Module 2 of Cloud Computing, which is Virtual Clusters and Resource Management. First, we are going to look at the definition and overview. Physical clusters, a collection of physical servers interconnected via physical networks, for example LAN. LAN is local area network. Next is virtual clusters, a group of virtual machines running on distributed physical servers interconnected through virtual network. Next is design issues in virtual clusters. Live migration of virtual machines. Moving virtual machines between physical machines without downtime ensures load balancing, fault tolerance, and resource optimization. Next is memory and file migration. Efficient movement of virtual machine memory and file data across different servers avoids performance bottleneck and ensures seamless transition. Next is dynamic deployment of virtual clusters. It enables scalable and on-demand provisioning of virtual machines, adjusts resource dynamically to avoid overloading and underutilization. Next is virtual cluster configuration and management. In that, traditional VM setup requires manual configuration by an administration. Poor configuration may lead to performance issues, for example, overloading, underutilization. Next is cloud-based virtualization, for example, Amazon EC2. Elastic computing. What is elastic computing? It allows users to dynamically create, manage, and scale virtual machines. Next is user account management. Customers can control virtual machine resources over time. Next is virtualization platforms and bridging mode. Platforms like Zen Server and VMware ESX Server support bridging mode. In bridging mode, all VMs appear as individual network hosts. VMs can freely communicate over the virtual network interface and self-configuration. Next is physical and virtual clusters. In physical cluster, it comprises of multiple physical servers interconnected via physical networks. Virtual clusters comprise virtual machine distributed across multiple physical servers and connected through virtual network. Like in physical cluster, they are interconnected via physical networks, but in virtual cluster, they are connected through virtual network. Next, in this figure, we can observe a cloud platform with 4 virtual clusters over 3 physical clusters shaded differently. We can observe this in this figure. Next is properties of virtual clusters. Flexible node configuration. Virtual clusters can include both physical and virtual machines. A single physical machine can host multiple virtual machines with different operating systems like OSs. Next is guest versus host OS. Each virtual machine runs on guest OS, which may differ from the host OS of the physical machine. Resource consolidation and utilization. Virtual machines help in consolidating multiple applications on the same physical server, enhances server utilization and improves application flexibility. Next is distributed parallelism and fault tolerance. Virtual machines can be replicated across multiple servers for better fault tolerance and disaster recovery. If a physical node fails, only the virtual machine running on that node are affected. Next is virtual machine failure does not impact the host system. Next, we are going to look at scalability and dynamic allocation. The number of nodes in a virtual cluster can increase or decrease dynamically, similar to P2P networks. Like in P2P networks, virtual clusters can increase or decrease dynamically. Next is physical cluster management and storage. Efficient virtual machine deployment and monitoring requires techniques like resource scheduling, load balancing, server consolidation, and fault tolerance. VM image storage. A large number of virtual machine images must be stored efficiently. Template VMs can be used to pre-install common software, reducing redundancy. Users can customize OS instances by adding specific libraries and application. In VM image storage, we can observe there are large number of virtual machine images must be stored efficiently. Template virtual machines can be used to pre-install common software, reducing the redundancy. Users can customize OS instances by adding specific libraries and applications. Next is dynamic cluster boundaries. Virtual clusters are flexible. Virtual machines can be moved, added, or removed dynamically. They can span multiple physical clusters and adapt to changing workloads. Like virtual machines can be moved, added, or removed dynamically. Like whenever it is needed or essential, they can be moved, added, or removed. They can span multiple physical clusters and adapt to changing workloads. Next is fast deployment and scheduling. Fast deployment involves quick setting up of operating system, libraries, and application on physical nodes. Virtual runtime Virtual machine runtime environment should switch efficiently between different users to optimize resources. Green computing aims to minimize energy consumption across clusters, not just on a single node. Live virtual machine migration shifts workload between nodes but can introduce overhead affecting performance. Load balancing improves resource utilization and system response times. Next is high performance virtual storage. Virtual machines use template images like pre-installed operating system and software to reduce setup time. Copy on write COW technique minimize disk space usage by creating small efficient backup files. Storage management should reduce duplicate blocks to optimize disk usage in virtual clusters. Like these are the some factors in high performance virtual storage. Next is live virtual migration steps and performance effects. Overview of virtual machine migration. In mixed host guest clusters, physical nodes run tasks directly while virtual machines serve as failover replacement. Virtual machine failover is more flexible than traditional physical failover but depends on host availability. Live VM migration enables a running virtual machine to move between hosts without serving interruption. Like these are the some overview of virtual machine migration. Here we can observe one figure. In this figure, we can see live migration process of virtual machine from one host to another. Next is steps of live virtual machine migration. First step is start migration, like step 0 and step 1. Identify the virtual machine to migrate and select the destination host. Migration is triggered automatically, for example, for load balancing or server consolidation. In step 2, memory transfer. The entire virtual machine memory is copied to the new host in multiple rounds. Changed memory pages are recopied iteratively until only a small portion remains. Next is suspend and final data copy, which is step 3. The virtual machine is temporarily stopped while transferring the final memory pages, CPU, and network states. This causes downtime which should be minimized for user experience. And the last step 4 and 5 are the virtual machine is restored on the new host, resuming execution. The network is redirected to the new virtual machine and the old one is removed. Next is performance effects of migration. Data throughput impact. Before migration, 870 MB per second. First memory pre-copy, which is 63 second, has 765 MB per second. Further iterations has 694 MB per second. Downtime only 165 milliseconds, ensuring minimal disruption. Minimal migration overhead, which is critical for dynamic cluster reconfiguration and disaster recovery, especially in cloud computing. Here in this figure, we can observe the effect on data transmission rate of virtual machine migrated from one failing web server to another. Next, we are going to look at the virtual cluster management approaches. First is guest-based manager, runs within virtual machines. For example, open Mosix on Zen, Solaris clusters on VMware. Host-based manager runs on physical hosts and can restart virtual machines after failure. For example, VMware HA. Independent cluster manager manages both host and guest systems, increasing complexity. Integrated cluster management it differentiates between virtual and physical resources for optimal efficiency. Next, we are going to look at role of virtual clusters. It is used in cloud computing, HPC, and computational grids. Enables dynamic resource allocation, quick failover, and efficient workload management. Live migration helps maintain uptime, reduce network congestion, and support flexible resource scaling. Next is migration of memory files and network resources. Due to high initial cost of clusters, including space, power, and cooling, leasing or sharing clusters is cost-effective approach. Shared clusters improve resource utilization through multiplexing and economies of scale. Early configuration and management system help define server-specific clusters and allocate physical nodes accordingly. When migrating a system to another physical node, several key considerations must be addressed. Like this is some of the concept in the introduction of migration, memory files, and network resources. In memory migration is a critical aspect of virtual machine migration, as moving virtual machines memory from one host to another must be done efficiently. Memory transfer size typically range from hundreds of megabytes to several gigabytes. Internet suspend resume, which is ISR technique. The ISR technique exploits temporal locality, meaning that memory states in the suspended and resume virtual machine instances are largely similar. Next is mechanism. Each file is represented as a tree of small subfiles. Both the suspended and resumed virtual machine instances contain a copy of this tree. Only changed files are transmitted, reducing data transfer. Next, we are going to look at limitations. ISR is useful when live migration is not required. Downtime is relatively high compared to live migration techniques. Like these are the limitations. Next, we are going to look at file system migration. For seamless virtual machine migration, a system must ensure a consistent location-independent file system across all hosts. Approaches to file system migration. First is virtual disk mapping. Each virtual machine is assigned a virtual disk that contains the file system. The entire disk is removed along with virtual machine state. Some challenges in this are high capacity disks make full disk migration impractical due to network overhead. Next is global distributed file system. The network accessible file system eliminates the need for file transfers. This reduces migration time and enhances accessibility. The third concept is ISR based distributed file system. The ISR uses distributed file system as transport mechanism for VM state transfer. The actual file systems are not mapped directly on the distributed system. Instead, relevant files are copied into and out of the local file system during suspend and resume operations. Some of the advantages are simplifies implementation by avoiding direct dependency on distributed file system semantics. Challenges are the VMM must store virtual machine virtual disk contents locally, which must be moved with the VM state. And the next concept is network migration in virtual machine environments. In this, virtual machine migration involves maintaining network connectivity for the VM without relying on forwarding mechanisms or redirecting mechanisms from original host. Like VM migration involves maintaining network connectivity for the virtual machine without relying on forwarding mechanisms or redirecting mechanism from the original host. This is essential for uninterrupted service during migration. Next, some key concepts are virtual IP and MAC addresses. Each virtual machine is assigned a virtual IP address and MAC address which are distinct from the host machine's address. These addresses must be maintained during the migration for network communication. The virtual machine monitor, which is VMM, maintains a mapping between the virtual IP MAC addresses and the VM. Next is network migration mechanism. When a virtual machine migrates to a new host, the migration must include all protocol states and the IP address of virtual machine. On a switched LAN network, the migrating host sends an unsolicited ARP reply informing other devices that VM's IPs have moved. This allows peers to update their network configurations to route future packets to VM's new location. If the virtual machine maintains its original Ethernet MAC address, the network switch can automatically detect the migration to a new port without requiring the further network configuration. Next is live migration of virtual machines. Live migration refers to process of moving a virtual machine from one physical node to another without interrupting the virtual machine's operating system or applications. Like live migration refers to the process where moving of virtual machines from one physical node to another without interrupting the virtual operating system or applications. This is essential for various enterprise workloads such as load balancing, system maintenance, and proactive fault tolerance. Next is live migration mechanism. The pre-copy approach is widely used in live migration where memory pages are transferred to the target node in multiple iterations. Like the memory pages are transferred to the target node in multiple iterations. The first round transfers all memory pages followed by subsequent rounds that only transfer modified pages. The virtual machine remains online during migration though there is a performance degradation due to the network bandwidth consumption. Next is pre-copy migration challenges. Performance degradation. The migration daemon consumes network bandwidth to transfer dirty pages, leading to performance degradation. Rate limiting can mitigate performance hits, but this prolongs the migration process. Like the rate limiting can mitigate performance hits, by this it prolongs the migration process. Next is convergence issues. Some applications may not have small writable worksets, causing difficulties in convergence, which might require additional migration iteration. It means that some application may not have small writable working sets, causing difficulty in converging them, which might require additional migration iterations. Next is memory transfer volume. The large volume of data transferred during the migration process is a key limitation in pre-copy based migration. Next is checkpointing, and to address the limitations of pre-copy migration, an alternative approach using checkpointing and trace replay like CRTR motion has been proposed. Like to address the limitation of the pre-copy migration, an alternative approach using checkpointing and trace replay, which are CRTR motions, has been proposed. CRTR motion transfer an execution trace file rather than the dirty memory pages, significantly reducing the amount of transferred data. Like CRTR motion refers to an execution trace file rather than the dirty memory pages, significantly reducing the amount of transferred data. Advantages like drastically reduces total migration time and downtime. Log files, which are execution traces, are much smaller than dirty pages, leading to a more efficient migration. Limitation in this are the approach is effective only if the log replay rate exceeds the log growth rate. The differences between the source and the target nodes may limit its effectiveness in some scenarios. Like these are the limitation where the approach is effective only if the log replay rate exceeds the log growth rate. The difference between the source and target nodes may limit its effectiveness in some scenarios. Next is post copy migration. Post copy migration transfers all memory pages at once, reducing the baseline migration time. However, it introduces significant downtime due to latency as memory pages are fetched from the source node before the VM can be resumed on the target node. Like post copy migration transfers the memory pages at once, reducing the baseline migration time. However, it introduces significant downtime due to latency as memory pages are fetched from the source node before the VM can be resumed on the target node. Let's look at the advantages in this. Reduced total migration time as the baseline transfer is done only once. Challenges in this are higher downtime compared to pre-copy due to latency in fetched pages. Next is compression based optimization for memory migration. With advancements like multi-core and many-core machines, there is possibility to compress memory pages to reduce the data transfer required during migration. Like with advancements in multi-core and many-core machines, there is a possibility to compress memory pages to reduce the data transfer required during the migration. Next is compression algorithm. Memory compression reduces the amount of data transfer during the migration. Like in memory compression reduces the amount of data to be transferred during a particular migration. Decompression is fast and doesn't require significant memory, thus improving migration efficiency. Next is live migration using Zen hypervisor. Zen is a widely used virtual machine monitor, which is VMM, that supports live migration by utilizing a send requiem model to transfer VM states between source and target hosts. Like Zen is a widely used virtual machine monitor that supports live migration by utilizing a send requiem model to transfer VM states between source and target hosts. Next is DOM0, the control domain. Like DOM0, the control domain manages the migration process, including the creation, termination, or migration of VMs across hosts. Like in DOM0 manages the migration process, including the creation, termination, or migration of VMs across different hosts. Example is given like live migration of VMs between two Zen enabled hosts. Like example is given below. In this, we can observe the various theoretical knowledge about live migration of VMs between two Zen enabled hosts. Next, in this figure, we can observe live migration of VM from the DOM0 domain to Zen enabled target host. Like we can observe source node and target node, and we can observe that the live migration of VM from DOM0 to Zen enabled target host, and some theory content related to that, like operations occur reducing it a one-sided interface. Like information about the live migration is given in this statement. You can go through this. Next is virtual cluster research and dynamic deployment. Several virtual clusters research projects have focused on dynamic deployment to improve the flexibility and resource allocation of VMs across the clusters. Like Several virtual cluster research projects have focused on dynamic deployment, which means ever-changing deployment to improve the flexibility and resource allocation of virtual machines across clusters. The first one is Cellular Disco at Stanford, a shared memory multiprocessor system designed to handle dynamic VM migration. Like a cellular disk at Stanford is a shared memory multiprocessor system which is designed to handle dynamic VM migration. Next is Indria Virtual Cluster, created to test parallel algorithm performance across VMs. Like Indria Virtual Cluster is created to test parallel algorithm performance across the virtual machines. COD and violin clusters, other clusters that are studied for performance and dynamic VM management. Like COD and violin clusters are other clusters that are studied for performance and dynamic VM management. Next in this table, we can observe the experimental results on four research virtual clusters. Like in this table, we can see the experimental results of four research virtual clusters. And in this figure, we can observe the COD partitioning a physical cluster into multiple virtual clusters. Like the COD partitioning a physical cluster into multiple virtual clusters can be observed in this figure. These projects demonstrate the potential benefit of dynamic VM migration within virtual clusters, ensuring resources are efficiently allocated based on demand. Like these projects demonstrate the benefits, like potential of benefits of dynamic VM migration within virtual clusters, ensuring resources are efficiently allocated based on demand. About the topic in Module 3 of Cloud Computing, which is Virtual Clusters and Resource Management. I hope you understood the video. Please download the notes if you have not downloaded the notes from our website. The website link is in the description. Stay tuned for further videos on Module 2 of Cloud Computing. Please like, share and subscribe to our channel.